assuming that the input voltage is a sine wave. So I'm gonna draw it here. So it's a sine wave. T V in. So this will be V max. That's minus V max. Now, and the diode are equivalent. So D1 and D2 are equivalent. So the characteristic of the diode looks like this. So you're gonna approximate that by this. So the voltage here is what we call VD when the diode is on. So this is VD and this is ID. So in this area, when the voltage is above the threshold, the diode is on, and then the diode will be off when it's below the threshold. So when you have a diode, when the diode is on, the current ID will be positive and the voltage across it will be VD on. So I can effectively replace it by a DC voltage source. So the current here is ID and the voltage is VD on. Now let's solve this network. So the goal is to find the output V0 T and sketch the transfer characteristic. Now, so because we have two diodes, we are going to distinguish four cases. So D1 on and D2 off. We have D1 off and D2 on. The third one will be D1 off and D2 off. And the last one is when both are on, D1 on and D2 on. Now we are going to go through this case by case, and then we're going to use that to find what the output is, and then use that to sketch the transfer characteristic. So case number 1, when D1 on and D2 off. So that I'm gonna redraw the network. So I'm gonna paste the network over here so I can see how the diode are positioned. So D1 on, that means we have that's VD on, and we have R1. So D2 is off. So we have R1 here, R2 there, So the direction of the current ID one should be like this, and this is V0. So V0 will be negative R2 ID1. Now let's try with KVL. Let's try KVL. So we have negative VI. Now minus VD on minus R1 ID1 minus R2 ID1 equal to 0. So this implies that R2 ID1, so R2 plus R1 ID1 equal to VI minus VD on. So we know that ID1 is positive because the diode is on. So when the diode D1 is on, ID1 is positive. So that means minus VI minus VD on is positive. This implies that VI plus VD on is negative. So VI is less than minus VD on. So when we put it all together, we have V0, which is negative R2 ID1. So what we have above is negative R2 ID1, which is negative VI minus VD on over R1 plus R2. So V0 is R2 over R1 plus R2, VI plus VD on. So when VI is less than minus VD on. So that is case number 1. I'm gonna box this. It's number 1. That's a case 1. Now case 2. For case 2, what do we have? We have D1 off and D2 on. D1 off, D2 on. So in that case, in this case, we have canary draw. So the input voltage is there, D2 on. So we have VD on and the current ID2. So ID2 will be positive. And then we have this constant voltage source V, and we have R2, and the voltage there is V0. Now let's write the KVL. So VI will be equal to VD1 plus V plus R2 ID2. So this implies that ID2 equal to VI minus VD1 minus V divided by R2. That must be positive. ID2 positive implies that VI is bigger than VD1 plus V, right? So because we want this to be positive, we know the resistor is positive, R2 is positive. So then V0, which is R2 times ID2, will be R2 times VI minus VD1 minus V divided by R2. So I should have found that from the KVL. So VD1 minus V. So, and when VI is bigger than VD1 plus V. So that's for case number 2. Box that. So case number 3 is when both diodes are off. So case 3, so D1 off and D2 off. So when I draw my network, it gives me this VI. So the diode are open. V R2. This is also open. R1. But the voltage here is VR2. So which is V0. So let me put V0 there. So because there's no current through that resistor R2, then V0 equal to VI. Oh, V0 equal to 0, right? Because that's R2 times 0 is 0 volt. Now let's do case 4. So for case 4, we have both diodes are on, D1 on and D2 on. So in that case, ID1 is positive and ID2 is also positive. Excuse me. So when I redraw the network, give me VI. So then I have VD on, have R1, so we have VD on, and we have V. Have resistor R2 here, and the voltage here is V0. So the current ID1 is positive, and this is ID2. So I can write my KVL right around this loop. So that gives me minus VD on, starting from the top, minus R1 ID1 minus V, minus VD on. Equal to 0. And let me write the KVL around the outer loop instead to get a condition on ID2, ID1. So if I did KVL around the outer loop, so that will give me VI plus R2, that times R2. Well, I could just stop right there. So when I write this equation, so let's stick to this equation. Now I can find ID1 from in this equation. So ID1, so R1 ID1 is equal to V minus V minus 2 VD on. Okay, so my ID1, so ID1 positive means that negative 2 VD on is positive, which is not possible because this is positive, V is positive, and VD on is positive, so that's not possible. So that means both diodes cannot be on at the same time. So at the same time, under these conditions, at the same time, under V positive and VD on positive. So so in that case, so both diodes cannot be on so at the same time. So one should be on, the other one is off, and vice versa. Okay, so both of them are off, which under that condition, then V0 equal to VI. So let's recap. So we know that for all cases V0 will be equal to, so let me see, case 1 will be equal to R2, so R2 over R1 plus R2, VI plus VD on, when VI is less than minus VD on. So that's condition number 1. Now condition number 2. Condition number 2. V0 equal to VI minus VD1. So that's, let me double check. So the second condition is this. Let me copy that. So we have VI minus VD1 minus V. So we have V0 is VI minus VD1 minus V, when VI is bigger than VD1 plus VD. And plus V, like the voltage V, and it's 0 otherwise. Okay, so can sketch the output. The transfer characteristic. Sketch the transfer characteristic. So here I have V0, have V in, so I have so let's look at this closely. So when VI is bigger than VD on plus V, so we have V0 equal to VI minus VD on minus V. So essentially it's VI minus VD on plus V. So it's in the form mx plus b. So m equal to 1, right? So 1, that's m. And this is the b, right? That's the b. So so if I have v plus vd on, then the slope will be equal to 1 in this case. Okay, so slope 1. So, and then so well, I did not sketch it correctly. So this graph, I should move down. Should move down there. Okay, and then this is minus VD1. So let's see, minus VD1. So in that case, the graph will be the slope of this graph, right? So V0 will be R2 over R1 plus R2, VI plus R2 over R1 plus R2, VD1. Okay, so the slope of this graph will be less than 1, so it's gonna look something like this. And then if you, so it's gonna be R1, so R2 over R1 plus R2. So let me write it correctly. So R2 over R1 plus R2, VD1. So this is the transfer characteristic.